Yo, what's up mga shorty pare dudes? So, today, we're going to learn about the basic integration rules. Well, I'm pretty sure that before you came to watch this video, you already have an idea about how to get derivatives of functions, in which you learn in your calculus 1 or in your differential calculus before. Well, first, let's define integration. What is integration? Integration is the process of finding an antiderivative or indefinite integral. It is actually the reverse process of differentiation. Now, let's consider function
f of x is equals 3x squared plus 7x minus 2.
If we try to find its derivative, we will get 6x plus 7. But, on the other hand, how could we get the antiderivative of 6 plus 7 into 3x squared plus 7x minus 2? This is where the basic integration rules will come in. Generally, there are 6 basic rules that I will discuss in finding integration or the antiderivative of a function, in which its formulas were only derived from the differentiation formulas. So now, let's discuss to you the important notations that you need to remember in finding the antiderivatives of a function. First is the integration symbol, which is the letter S, like, you know. And second, the integrand, which is the f of x. And the plus c constant, which is always put at the end of every antiderivative function. And it is very important. So, before we discuss the basic integration rules, let's have a quick review. Pause this video and try to find the derivative of the given function presented on your screen. If you try to find the derivatives of each one of these, they will come up with the same answer, which is the 3x squared. As you've noticed, this plus 5 minus 4 and plus 13pi was disregarded in our final answer. So, to sum it all up, this is important when getting the antiderivative function, since, as I've said earlier, it is the reverse of the derivatives and the constants is unknown, such as these numbers. So that means that there will always be a constant plus c or an arbitrary plus c on the end of every antiderivative function. You get that? First one is the power rule for integration. So, the formula for the power rule for integration is the integration of x raised to n dx, that is equal to x raised to n plus 1 over n plus 1 plus constant c. So, let's have this simple function as our first example. So, as what we've remembered from the formula a while ago, the formula for the power rule for integration is equals to x raised to n plus 1 over n plus 1 plus c. So, let's define what is letter n here in our given function. N is equals to the 3. So, if we substitute it, x is equal x3 plus 1 over 3 plus 1 plus c. To give you some few tips, always remember that the exponent here is always equal to the denominator of what we are getting. So, with this, x raised to 4 over 4 plus c. And there we have our answer. So, if you encounter a function like this, or a function that has a square root, we'll need to simplify it. So, here in our example, we reciprocal the 1 to the x raised to 5. Then you get x raised to negative 5 over 1. But the 1 is invisible, so we'll just erase it. Also the integration. dx. Now we can perform the power rule. So, the integration of x raised to negative 5, 1. And that's what I said earlier, that the exponent is just equal as the denominator. So negative 5 plus 1 also. So, if we try to compute this, and the plus dito lang. If we try to compute this, we'll get x raised to negative 4 over negative 4 plus c. And that's our final answer. It is that simple lang. So, our next rule is the constant rule for integration. The formula for this is the integration of c dx is equal to cx plus c. So now, let's move on to our example. So, first example is the integration of 6 dx. So, from what we remembered from the formula earlier, the constant is equal to cx plus c. We have to identify what our c here, and it is the number 6. So, we'll just substitute it. So, this is equal to 6x plus c. That's our final answer. The next rule is our constant multiple rule. In this rule, if there is a constant in front of an integrand, we'll just need to move this constant outside the integration. So, it is moved from here, then there. So now, with our example, integration 3x squared dx. First, we'll put this outside of the integration. So it will be 3 integration of x squared dx. Now we can perform the integration here, or the power rule that we have learned earlier. 3 integration of x 2 plus 1 over 2 plus 1 plus c. So, 3, then compute this in parentheses, x cubed over 3 plus c. So, plus c. Then, we can now multiply these two, the constant and the antiderivative we get here. Then, it will become 3 over 3 x cubed plus c. Hindi na kasha. So, I guess I'll erase this. This will be 1, or it's invisible naman, so hindi natin sulat, x cubed plus c. This is the example that we used earlier as the quick review for the derivatives. So as you can see, tama siya. Now, for our sum and difference rule, expressed in this formula, which is the integration of m of x plus minus g of x dx is equal to the integration of m of x dx plus minus gx dx. So, in this function, in this example, we'll first compute the answer between the x minus 3, x plus 2. Since we need to simplify first the function before we can get to the rule. Using the for method, we can find and simplify this equation. So it is equal to the integration of x squared minus x minus 6 dx. So So after that, we'll distribute the dx inside parentheses. Is equal to the integration of x squared dx minus x dx minus 6 dx. After that, we can now proceed to the integration of it. Yung parang gagawin na dito is yung mga napag-aralan nating mga rules kanina na pinagsama-sama lang. So, katulad dito, power rule lang muna gagamitin natin dito. X 2 plus 1, x 2 plus 1 over 2 plus 1 minus x dx. Siyempre, there is an invisible 1 over here, so we can 1 plus 1 minus the constant rule that we discussed a while ago, 6x. It will going to be 6x plus c. After that, we're going to equate it. This is going to be x cubed over 3 minus x squared over 2 minus 6x plus c. And that's our final answer now. So for our next rule, it is the indefinite integral of x raised to negative 1, or is known as the indefinite integral rule of logarithmic function. So why is it called x raised to negative 1 rule? X raised to negative 1 is equals to 1 over x, which is also equals to the derivative of the natural log or the ln x. The formula that is used for this is the integration of 1 over x dx is equals to the natural log or the absolute value of natural log or the ln x. So here is our example. Integration of 1 over x dx is equals to 5 the natural log absolute value of x and the plus c. Then, yeah, it's already done. This is the antiderivative na equation natin. No problem. So, for our final rule, the indefinite integral of exponential function rule. Okay. The formula for this is e raised to kx dx is equals to
1 over k e raised to kx plus c.
Let's try solving it with an example so we can understand it more. So, in finding the integration of our given, let's first identify what is our constant k here. Constant k here based on the formula that I have given to you earlier a while ago. So k here is the 2. Applying the formula for this, which is the e raised to k x over the k, which is the 2 plus c. Then there we have already our answer. It is that simple lang naman. So that's all. I hope you understand something here today.